that is the searching techniques, or you can say search techniques. Search techniques in non-linear programming problem. Non-linear programming problem क्या होगी? If at least your objective function or constraint is not linear, then you say that is your non-linear programming problem. अब तक जो हम डील कर रहे थे वो लीनियर थी. जो मेरे ऑब्जेक्टिव फंक्शन होता था उसमें कोई एक्स की पावर नहीं होती थी, ना ही वो मल्टीप्लाई में होते थे. सो वी हैव ओनली डिग्री 1, so that we were dealing with the linear programming problem. Non-linear is either your objective or any of the constraint, right? If at least one, even one constraint is your not linear, then you call this is your non-linear programming problem. The analytic solution for non-linear programming problem, we will do it later. Firstly, the search technique is for the finding the approximate solution, because when you have non-linear programming problem, linear programming problem में तो मेरा क्या होता था, the solution lies on the vertex, so I can move from vertex to vertex, right? But अगर suppose यही example, मतलब ये यहाँ पे मेरा हो कि minimize x1 plus x2, but the constraint I have x1 square plus x2 square less than equal to 1 and x1 and x2 are greater than equal to 0. So this is your circle, right? Constraint, the feasible region is circle, right? And in this, the minimum point is 0, 0. That is the optimal solution 0, 0 is lying inside the feasible region. So it is quite difficult to find the optimal solution in non-linear case, right? So you have studied numerical that when it is not easy to find the solution, we can go for approximate solution. So the searching techniques which are based to find the solution in non-linear programming problem, that is based just because of this, that are on the approximate solution. And for the searching techniques, we are considering non-linear programming problem without constraints. That means we have only one objective function. Clear? We will do even non-linear programming problem in two ways, that we will solve with the constraints and we will solve without constraint when we go for analytic solution, right? So we are considering NLPP without constraints. Clear? Just because for the non-linear, the solution can lies in the feasible region and it is very difficult to identify. That's why we are going for the searching techniques. For that, you should know one definition, unimodal function. Unimodal function is one that has one peak in the given interval AB. In the given interval AB, that is either it has maximum value or minimum value in the given interval AB. When you talk about your approximate solution, NA maybe when you talk about that interval in which you are talking about, in which you are finding the solution. Is it clear? So graphically what it represents, so what it is saying, that a function which has only one peak means the function can be like this. There will be only one peak. So if it a function like this, it has only one peak in the interval. This is my interval A in which my function is lying. So you can see here we have minimum value. On the other hand, you can say the function has peak, can have peak upward. So what it will be like this? So it will be like this. Here it has one peak and this value is my maximum value and here your maximum lies. And this is my interval A and this is the B. Is it clear? So this is unimodal function. So we have some result that we will use in searching techniques. So result is, first is, if x1 is less than x2 implies function's value at x1 is greater than f of x2, then the interval where minimum lies मिनिमम की बात करें तो p कौन सा फंक्शन होएगा व्हेन वी आर टॉकिंग अबाउट यूनिमॉडल फंक्शन, दिस इट विल बी लाइक दिस फंक्शन. ठीक है, अब आप कह रहे हो कि आपका जो x यहाँ पे आपका मिनिमम लाई कर रहा है, राइट, एंड हियर इट आल्सो लाइंग योर मिनिमम, एंड दिस इज योर पॉइंट A and this is your point B. You are saying x1 is less than x2 and the function's value at x1 is greater than x2. That means here can be do like this, x1 is less than x2 but the function's value at this is greater than x2. ठीक है, तो यहाँ पे आपका मिनिमम किस इंटरवल में लाई कर रहा है, A, that is x1b. ठीक है, so interval here lies between x1b and x2b. इसी इंटरवल में आपका मिनिमम लाई कर रहा है, इससे अलग तो इंटरवल नहीं है. यू हैव दिस इंटरवल वेयर योर लाइंस मिनिमम इज लाइन. A और B तो हमें गिवन ही है, वी हैव इंटरवल, उसमें तो मिनिमम है ही है. So when we have x1 and x2, so this is the interval where my minimum is lying. I can take x1b and x2b. ये केस है, और क्या हो सकता है, ऐसे भी तो हो सकता है. Here also your x1 is less than x2. छोटा function's value x1 is greater than. So this can be your point x2. Here you can see x1 is also less than x2, but the function's value at x1 is greater than the function value at x2. So in this, what is the interval? That is ax2, x1 x2 and x1b. That means when we have this, इसके अलावा तो और कुछ नहीं पॉसिबल हो सकता, राइट, क्योंकि अगर आप इस साइड दोनों x1 और x2 ले लोगे, फंक्शन की वैल्यू x1 पे x2 से छोटी हो जाएगी, राइट. सो दिस कैन बी द ओनली केसेस. सो व्हाट इज द कॉमन इंटरवल इन विच माय मिनिमम लाइन? अब फंक्शन x1 और x2 कहीं पे भी हो सकते हैं ना मिनिमम के, सो दैट इज x1b. क्लियर? यस और नो? This we will use, right, that when we have checked x1 x2 less than and the function is of minimization, so we can take this next interval, right. Second case क्या हो सकता है, that x1 is less than x2 implies function's value at x1 is also less than the function's value at x2. So what can be the case here? So then, any doubt? Any doubt? Then the minimum lies in interval. We will also check in this case. So we are finding the minimum So we have, this is the minimum value, right? And this is my interval A, and this is my interval B. And we have this, here we can also have two possibilities. So when you have x1 is less than x2, तो केस क्या हो सकता है कि x1 यहाँ है, ठीक है, x2 सपोज आपका यहाँ है. Here your x1 is less than x2 and your function's value is also less than function's value at x2. So what is the interval in this case? We have interval x1, x2, right? And we have interval x1, b. A, x2 also, right? And in this case, what can be the case? जो हमने पिछले में discuss किया था, that here can my lie x1 and here can lie my x2. So here the function x1 is less than x2, but the function value at x1 is less than x2. So what is the interval in this case? The interval is lying between a x1 और आपका इंटरवल किस में आ रहा है? दिस इज ax2. So what is the common interval? Common interval is this ax2. So that we will consider कि जब हम अपने क्वेश्चंस करेंगे, अगर हमारी x1 और x2, x1 की वैल्यू लेस देन x2 आ रही होगी और हम फंक्शन की वैल्यू चेक करेंगे, तो नेक्स्ट अप्रोक्सीमेशन के लिए हम ऐसे कॉपी करेंगे अपना फंक्शन, ठीक है? मैक्सिमम के लिए क्या होगा? इनका उल्टा हो जाएगा, ठीक है? सॉल्व कर लोगे केसेस? मैं लिख दूं सिर्फ, इफ x1 is less than x2 and function's value at x1 is greater than function value at x2, then the common interval that you can find, then common interval will be उल्टा हो जाएगा यहाँ पे ax2 because negative of that. And if x1 is greater than x1 is less than x2 and function's value is also less than function's value at x2, then the common in this case will be your x1 to b. ठीक है? क्लियर है ये चीज, राइट? The first technique in your syllabus is Fibonacci series search technique. Fibonacci search techniques के लिए आपके Fibonacci numbers क्या होते हैं? You have number f0, suppose मैं कह रही हूँ f1, f2, f3, f4, f5, f6, f7, f8. कैसे लेते हो? पहले नंबर 1 1, फिर सम 2 + 1 3, 3 + 2 5, 5 + 3 8, 8 + 5 13, 13 + 8 21, 21 + 3 that 13, that is coming out to be your 34. तो सीरीज आप कैसे चलाते हो? दैट f0 is your 1, you take f1 is 1 और फंक्शंस की वैल्यू नेक्स्ट n पे क्या होती है? फंक्शन की वैल्यू n-2 प्लस फंक्शंस वैल्यू एट n-1 फॉर n ग्रेटर देन इक्वल टू 2 के लिए, यही होती है. अब हम टेक्निक चला रहे हैं, ठीक है? When we have to approximate the number, ठीक है? We are not going to the proof कि x1 और x2 कैसे आए. I am just writing the formula, right? So you will take in this case x1 is a plus function's value at n-2 divided by function's value at n, right? Into L0. L0 is the length of the interval, which is given to us. And x2 we will consider a plus function's value at n-1. There is a logic for that why we are considering, right? So fn, and this is also your L0. Then we further check that x1 is less than x2 और function की value क्या हो रही है, then we change the interval on that basis. x1 and x2 approximations नहीं, जैसे हम फॉर्मूले में लेते थे xn plus 1 लेते थे कि a plus b by 2 मिड पॉइंट के लिए लेते थे ना बाइसेक्शन, फिर आप चेक करते थे कि कौन सा इंटरवल लेना है. न्यूमेरिकल में वैसे वो भी करते थे, जैसे न्यूटन रेफसन में xn plus 1 क्या होता था, xn माइनस फंक्शन वैल्यू एट xn डिवाइड बाय इट्स डेरिवेटिव, है ना, तो वैसा कुछ करते थे. तो दैट इज द फॉर्मूला. यस, so x1 and x2 we have to consider this. Then we will check in the next which interval we have to take. One, you will choose that where you should go, that is the measure of effectiveness. In this, you consider L naught is the length of interval. And Ln length, or you can say width, length of interval of uncertainty after n iterations. That will be given to you कि आपको कितना लेके चलना है, ठीक है. So in that basis, your measure of effectiveness, the formula will become alpha is equal to Ln divided by your L naught. Clear? So now we are doing the example for the Fibonacci numbers, that will be clear to you, right? So example is that minimize the functions x, that is x into x minus 2, and your function is lying between 0x and 1.5 within the interval of an uncertainty, within the interval of uncertainty 0.25 into your L naught. जितनी भी आपकी L naught होगी उसका 25% मतलब क्या है, आपका uncertainty का वो है, ठीक है. So from here you will find firstly the measure of effectiveness, that is your alpha. अल्फा आपका क्या था, Ln डिवाइड बाय योर L naught. अब उसने अनसर्टेनिटी का मेजर कितना दिया, इंटरवल 0.25 इंटू योर L naught. L naught चाहे आप पहले निकाल लेना, चाहे यहाँ पे आपका L naught जरूरत ही नहीं है, तो यू कैन जस्ट राइट L naught डिवाइड बाय L naught. अगर आपको इंटरवल दिया जाता है कि ये है, then you can firstly calculate L naught, that yes, L naught will be here your 1.5 minus your 0, that is the length of the interval. तो अगर आपको सिंपल दिया जाता कि सिर्फ 25% ही है या इतना इंटरवल लेके चलना, then you can calculate. So it will always be less than equal to 1, right? So this is coming out to be your 0.25. And in the case of Fibonacci series, we have measure of effectiveness is alpha. In the case of this is 1 by Fn, right? So from here we will have 1 by f of n, that should be less than equal to the 0.25, क्योंकि measure of effectiveness उसका इतना है तो इससे कम ही होगा uncertainty का. So that you will have 1 by Fn, or you can say that is 1 by 4, 25 by 100. So you can say Fn is greater than equal to 4. n आपको पता चलेगा कि आपको कितनी आइट्रेशंस परफॉर्म करनी पड़ेंगी अपना लेवल अचीव करने के लिए कि वो अप्रोक्सीमेट सोल्यूशन जो है वो थोड़ा क्लोज हो जितना आपका आंसर है, राइट? सो when you will do like this, Fn is greater than equal to 4, और Fn की सीरीज आपने ये लिख रखी है, ठीक है? Fn 4 से कहां बड़ा हो रहा है, F4 पे. That means you will have, which implies F4 is actually your greater than actually F4 is your 5, right? And 5 is greater than 4, which implies n is your 4. Fine. So that means your answer will be at least you have to do for 4 iterations. So how we will start? We have given the approximation. Firstly, first iteration के लिए we will start from the back in this case, right? Because we have formula fn minus 2 divided by fn. तो आप 1 से start नहीं कर सकते, 1 minus 2 does not make sense. हम back से start करते हैं. So in this case we will consider first n is equal to 4, right? L naught is your 1.5 minus 0 and the interval हम पहले x1 निकालेंगे. यहाँ पे जो मेरा इंटरवल है वो क्या है, right? And that is your 0, 1.5. This is means this is your a and this is your b. तो x1 का फॉर्मूला क्या था? a plus fn minus 2, that means 4 minus 2 divided by fn into your L naught. Clear? a आपका कितना है? 0 plus f2 divided by f4 into your function, this is 1.5. यहाँ पे f2 की वैल्यू डालोगे, f4 की वैल्यू, and then it will be coming as 0.6. Clear? Yes or no? Fine. x2 का फॉर्मूला क्या है? a plus fn minus 1 divided by fn into L naught. So this is 0 plus f3 divided by f4 into L naught. Substitute the values and you are getting 0.9. Clear? अब वही नेक्स्ट हमने आइट्रेशन के लिए इंटरवल कैसे चेक करना है? x1 यहाँ पे क्या आ रहा है? x1 इज योर लेस देन x2. ठीक है, फंक्शन की वैल्यू चेक करोगे x1 पे, मतलब फंक्शन में क्या पुट करोगे? 0.6. सो आंसर इज कमिंग आउट टू बी योर माइनस 0.84 and function value at x2 it is coming out to be your minus 0.99, right? So which implies x1 is less than x2, but your function's value at x1 is greater than function value at x2. और हमारा ऑब्जेक्टिव फंक्शन क्या है? मिनिमाइजेशन. सो द इंटरवल विल बी, क्या निकाला था हमने इंटरवल? x1b, right? So that means the value for the next iteration is x1b. So here we will have 0.6 and b is my 1.5. So my minimum is lying between 0.6 and 1.5. Clear? So next we will perform second iteration. Second iteration के लिए आपका n क्या हो जाएगा? n you will have 3. अब आपका इंटरवल a b इंटरवल क्या है? 0.6 and 1.5. So now you will calculate L naught. L naught will be 1.5 minus 0.6. x1 will be a plus function's value at f3 minus 1, 3 minus 2 divided by f3 into L naught. So this is coming out to be your 0.9 and x2 is a plus f3 minus 1 f3 into L naught. This is coming out to be your 1.2, right? Clear? Now here you can also see your x1 is less than x2. Next you have to check function value at x1. Function की value x1 में जब substitute करोगे, it is coming out to be your 0.99 minus, and the function value at x2 it is coming out to be your minus 0.96. So in this we have x1, x2 implies function's value at x2 is less than x2. So interval in this case will be, कितना निकाला था हमने इंटरवल? ax2, right? अब यहाँ पे a मेरा कितना है? 0.6 and x2 is my 1.2. Clear? I will complete, then I will stop, right? The third iteration, if you will perform, and in this case n will become your 2, right? And You will say L naught now is your 0.6 and 0.1 to 1.2. This is your interval AB. Sorry, this is the interval AB. And L naught will be your the difference of 1.2 minus 0.6. You will calculate x1. A plus functions 2 minus 2 divided by f2 into your L naught. It is coming out to be 0.9. And an x2 A plus f 2 minus 1 divided by f2 L naught. It is again coming as 0.9. अब हमें तो interval चाहिए, right? So you can see from here that your x1 is equal to your x2. So what, and your minimum value is lying in this interval 0.6 to 1.2. So what we can do, we can consider the value of x2 just greater than x1, so that we can decide the interval in which my value is lying. So we can consider x2 just greater than x1. छोटा क्यों नहीं ले सकते? Because this is the interval, right? So 0.91, क्योंकि वैल्यू इंक्रीज हो रही है ना, 0.6 से 1.2 तक जानी है और वैल्यू जो है हर बार इंक्रीज हो रही है, ठीक है? तो पहले 0 वाला इंटरवल आया था, देन वी हैव इंक्रीज, सो दैट्स व्हाई वी आर टेकिंग द ग्रेटर वैल्यू, राइट? सो 0.91 हम कंसीडर करेंगे. सो दैट मीन्स एट x2, this is my x2 dash is my x2 0.91, and your x1 is less than x2, implies फंक्शन की वैल्यू इस पॉइंट पे आपकी आ रही है. This is coming out to be your minus 0.99, and at this point fx2 dash, it is coming out to be 0.981. So that means function value x1 is also less than function value at x2. So which implies interval will be ax2, that is the interval 0.6, and x2 is your 0.91, or you can say consider 9 only, because we have considered x2 is this value. This we have just considered for checking the interval. So we can consider 0.6 and 0.9. नेक्स्ट आइटरेशन करोगे. फिबोनाची सीरीज आपकी कब तक वैलिड है? व्हेन यू हैव fn फॉर्मूला एंड ग्रेटर देन इक्वल टू 2 के लिए. तो आप 2 minus 2 ऑलरेडी कर चुके हो, दैट मीन्स यू विल नॉट परफॉर्म द नेक्स्ट आइटरेशन. So in this we will have optimal solution is that will be the average 0.6 plus 0.9 divided by 2. So that is coming out to be your 0.5, and optimal value you will put this value function क्या था, x into x minus 1, x minus 2, ठीक है? So this is coming out to be your minus 0.9375. This is the approximate value. You can say approximate optimal solution. Okay, clear up to here? Yes or no? Thank you. इसके